Welcome back to part 3, in which we're going to do several exercises. First of all, we're going to develop a function to round a number to the nearest cent, which would help us when we're dealing with financial applications that require the accuracy to be rounded to the nearest cent. That is, to the nearest 100th place. Then we're going to generalize this function so that it can support rounding to any decimal place in case we have need of rounding to the nearest 100th place or to the nearest 1000th place. Then we'll demonstrate how we can rewrite the first function to utilize this function. Finally, we'll organize our functions into a utility class so as not to pollute the namespace. First, let's write a function to round to the nearest 100th. We start by using the keyword function and providing a sensible name for this. Round to cents would be a good candidate. We need to provide one function input to this, the value that we're going to round. We'll call it amount. The function body goes inside the opening and closing curly brackets. Recall that one of the primary purposes of using functions is for code reuse. Once we've written a function, we can reuse it elsewhere. We already have a function in the standard math library to round. Unfortunately, it works by rounding to the nearest one spot. Let's adapt that function so that we can round to the nearest 100th spot. We can do that by first multiplying our amount by 100. By doing this, the 100th spot is now the 1 spot, and we can round normally. Now that it's been rounded to the nearest 1 spot, we can correct the amount by dividing by 100. Finally, we need to return our result. This could be more compactly written as follows. Let's test our function with a few values. $100.3214 correctly rounds down to 0.32. Let's try another value. It correctly rounds up to 0.33. We can generalize this idea by providing a second parameter to our function to tell us exactly what place you want to round to. For example, a value of 0 would be the regular round function that you want to round to the nearest 1 spot. A value of 1 would mean that you want to round to the nearest 10 spot. A value of 2 would mean that you want to round to the nearest 100 spot. Negative values likewise. Again, demonstrating code reuse, we can use the math.pow function to multiply by a power of 10 using place. As before, we can rewrite this to be a little bit more compact. Let's again test our function. This should round to 132. As we described the function earlier, this should round to 130, but it doesn't. Recall that we were multiplying and dividing by a power of 10. To correct for this, we actually need a negative power of 10 here. And we get the expected result. This should round to 100. This should end up rounding to 0. Let's try it in the other direction. A negative 1 would indicate rounding to the nearest 10th spot. By doing this generalization, we can see that the original function round to cents is simply a special case of the round to place function. So let's replace round to cents with a call to our function. and test it again. It still works. As a final step, let's avoid polluting the namespace with these two functions by placing them into an object. We will need to change the syntax accordingly. Now when we need to invoke these functions, we do so through the roundUtils object. Placing code into functions organizes that code and makes it reusable. Placing functions into objects organizes related pieces of code so that we prevent polluting the namespace.